Okay, now let's look at example 1. This is exactly the same as what we just analyzed. Okay, we just give some numbers so we can do calculations. So for the beam and loading shown here in this figure, we compute the downward deflection of the beam at point D, where we're calculating point D, this free end. As we just analyzed, for this case, we can just split it into 3 beams: beam 1, beam 2, and beam 3. The beam 1 is the cantilever part. The beam 2 and beam 3 are the simply supported part, but we need to calculate the theta 2 and theta 3, then use these 2 triangles to solve another 2 components of the deflection at point D. Right? So here, let's look at the beam 1 first. For the beam 1, here is we need to find an equation first. Well, obviously, it's a cantilever beam, and you just add a concentrated load PD at the free end. So this will be our equation 21 or equation 20, since we're calculating the maximum deflection, right? So we can directly use equation 20. And here this we need to find the L and the P, right? So the L in this case equals 2 feet. Right, so that is the CD, right, 2 feet here. And the P equals 12 kips. So in this example, since the EI is given with a unit of kips square foot, so we do not need to, it's not necessary to convert everything into inch. We just keep using foot, it's okay. Okay, so here, just from equation 20, our delta 1, the first component, delta 1 equals negative P L cube over 3 EI. This is negative P is 12 kips by 2 cube over 3 times 2,200. And the result is a negative 0.0145 feet. So this is a downward deflection, right? Obviously, this will be a downward deflection. And here is our equation 20. This is the number of equation in the table. Now we can look at beam 2. The beam 2 is a simply supported beam, and the P is added at point B. Right? Here the P is added at a point at B, at the point B, which is A from the left support. And B from the right support. Right, this is our equation here. Okay, this is our case. Okay, it's not added at the middle span. It's a random point, A from the left support and B from the right support. So we can use if we're calculating the deflection, you can use 6 or 5, but here we only need to calculate the slope at the far end. Okay, so we should look at equation 4. Here, as we are calculating the slope at point C, right? This is theta 2, this is the C, this is the far end. So we should select one of the two equations. You have two equations here. So we should select this equation, okay? This is for the far end here. It's a positive slope. So here our theta 2 can then be calculated as P by A L square minus A square over 6L EI. And that the P is 12, A is 2 here, right? The A is just AB, right? AB is 2 feet. By L square, L is 6, so L is just AC, AB plus BC, it's 2 plus 4, it's 6 square minus 2 square over 6 times L is 6 and EI is 2,200. And the result will be a very small angle. This will be 0.0097 radian. So as we analyzed in the previous slides, and here the this components delta 2 prime will be, here you just look at this triangle, right? Here we get a triangle, and this angle here equals the delta 2, which is calculated. Here, strictly speaking, here is a CD, and the CD value is 2 feet. Right, here is 2 feet. Here we get a LCD by delta 2. And here, strictly speaking, here should be sine theta 2. But since this angle is very small, so we can ignore it. We can just directly use delta 2. Okay, so here is 2 by 0.0097. So you get 0.0194 feet. Is this a downward or upward deflection? This is a positive number, right? It's upward deflection. You can also see that from here. It's an upward deflection. And here, this equation we used is the equation 4 in the table, right? But it is the second one, the theta 2, the far end of the equation 4. Then it's a beam 3. Beam 3 here. And here the M is added at the right end, right? It's M added at, I have to change the color here, at the right end. Why I need to emphasize this right end, later you will know, okay? It's M is added at the right end of the simply supported beam. And the value of M it's just a PD, right? PD by CD. It's just a PD by LCD. It's 12 by 2. I got 24 kips feet. So strictly speaking, this should be a negative bending moment, right? Since it will make the section AC cry. So it will be a negative bending moment. But here it doesn't matter. So we just keep in mind that the direction of it will not affect the calculation. You just need to keep in mind this bending moment will make the point D deflect downward. Okay, this will be another downward deflection. Keep this in mind, then you will not make mistake. Now here the L in this case equals 6 feet. Right. Then we need to select the equation to solve this problem, to solve this deflection. Okay, so here in this table, you can see the cases here. Right, this is the case fit what we're calculating. But in this case, the bending moment is added at the left end. The bending moment M is added at the left end, left support. But in our case, it's added to the right end, right support. Okay. So here, obviously, if we want to calculate the slope at a point C, we should use equation 7. But 7 also has two components, right? Theta 1 and theta 2. And here, in this beam given in this table, here is theta 1 at the left end, here is the theta 2 at the right end. But in our case, since the M is added at the right end, so which equation you will select? Theta 1 or theta 2? Which equation you will select? Obviously, it should be theta 1. Right? We will use this equation for our calculation in the example. So here the theta 3 in our case here, the theta 3 will be calculated as negative ML over 3 times EI. This is negative 24 by 6 over 3 times 2200. Then you get a negative 0.0218 radian. So then the delta 3 prime will be calculated. Here we're looking at this triangle. Okay, this triangle, and here the theta 3 has been calculated, and that equals this angle here. This is also theta 3. So in this triangle, the delta 3 prime equals LCD by theta 3, and that is 2 by negative 0.0218. It's a negative 0.0436 feet. But here it's a downward deflection. So at the end, we just summarize everything. The overall deflection at the point D will be delta 1 delta 1 we calculated here plus delta 2 prime which is here plus delta 3 prime which is here. Okay. So here the first component is a negative 0.0145. Second component is positive. It's an upward deflection, right? 0.0194. And the third component is a negative value again, negative 0.0436. Then the final deflection value is negative 0.0387 feet. Okay. So this negative sign is telling you that this is a downward deflection. Okay. This is the first example.